quotients of radicals. So just a reminder that products is dealing with multiplication and quotients is the result of division. Let's do some review of the anatomy of a radical first. So here's my radical, the cube root of x. That 3 that indicates my cube root, that is going to be called the index. Okay, that is the index, and my x over here under the radical sign is called the radicand. So hopefully that is review for you. And it's important to note that you can only multiply radicals if they have the same index. So you cannot multiply the square root and the cube root. You cannot combine them with the product property. It has to have the same index. So that brings me to the product property of radicals. The product property says that the nth root of x times the nth root of y is equal to the nth root of x times y. So basically what this comes down to is you are keeping your index and you're going to put the x and the y together. If they're being multiplied, then you can multiply them together inside of the radicand, inside of one radicand. They can share. Okay, so just like they can share, that means you can also split them up. It can work in the reversed. So let's take a look at these first two examples. I have the square root of 2 times the square root of 3. Since they have the same index, I can make a big square root and just put 2 times 3 inside of the radicand. Now I can simplify. 2 times 3 is equal to 6. Okay, so we have the square root of 6, and that's it. Let's look at another example. I have the square root of 5 times the square root of 7. Because of this product property, and I can see that they have the same index, it's just the square root, I can make a big square root and in the radicand put 5 times 7. So 5 times 7 is 35. So this is just equal to the square root of 35. So we're going to look at some practice problems. I know big numbers, but we're going to split it up. Okay, just like I told you that the product property can work in the reverse, that is what we're going to do. We're going to split up 900 into 900 as a product of two factors, and they don't have to be two equal factors at the moment, but just off the top of your head, 900 is divisible by, I'll give you a hint, starts with the 100. Okay, so 900 is divisible by 100. It is just 9 times 100. So I'm going to split that up under the radicand. So it's the square root of 9 times 100. And wouldn't you know that they're both perfect squares? So since this is pre-algebra, we're going to make this easy because this is an introduction to radicals. In Algebra 1, it will get more complicated, but this is a good intro. So I'm going to split them up. They were under the same radical sign. I'm going to split them up so they have their own radical signs. So that is just equal to the square root of 9 times the square root of 10. So what is the square root of 9? Trace, it's 3. Okay, and then the square root of 100. Hopefully you recall that it is 100. So really this could be simplified as 3 times 100. I'm at 3 times 10. Wow, I could totally read. Okay, so 3 times 10 is equal to 30. Let's look at our second problem, the square root of 1,600. Again, it looks like a big number, but I can already see that this is divisible by 100. So I'm going to split this up as a product of two numbers. 1,600 is really just 16 times 100. So I have them under the same radical sign right now, but now that I can see that it is a product of two numbers, I'm going to split them up. Okay, I'm splitting them up. Don't tell their moms. That's the square root of 16 times the square root of 100. So the square root of 16 is 4, and the square root of 100 is 10. So that simplifies down to 4 times 10. 4 times 10 is just 40. Okay, so that had to do with the product. Now we're going to look at the quotient property of radicals. So the quotient property of radicals says that If x is greater than or equal to 0 and y is greater than 0, then the nth root of x over y is equal to the nth root of x over the nth root of y. So same basic concept. Basically what you're getting down to is that if they have the same index and they're under one radical sign, you can split them up with one on, got to keep it in order, right? If x is on top, x needs to stay on top, and then y is on the bottom. And this can only work if y is greater than 0. Not equal to 0, greater than 0. So let's look at some practice right here. So I have the square root of 4 over 9. The square root of 4 over 9 is equal to 2/3. Now the square root of 4 over the square root of 9, the square root of 4 is 2. Okay, and the square root of 9 is 3. So that is equal to 2/3. So that's just to show you that that this property works, this quotient property works, that the square root of 4 over 9 is equal to the square root of 4 over the square root of 9. Let's do some more practice. So feel free to pause the video and work on these on your own, and then play it when you are ready to check the answers. Number 1, the square root of 25 over 4. So according to the quotient property of radicals, I can split this up, right? I can make it the square root of 25 over the square root of 4. And wouldn't you know that they're perfect squares? The square root of 25 is just 5, and the square root of 4 is 2. So I'm going to rewrite this as 4 over 2. And that's it. I mean, you can simplify to 2.5 if you want, but 5 over 2 is fine. Let's look at number 2. The square root of 8 over the square root of 2. So this is going to look a little different because 8 is not a perfect square. So I'm going to see what I can do about splitting 8 up using the product property and see if I can simplify it that way. So start with that. 8 is just 2 times 4. So with that in mind, I can say that the square root of 8 is equal to the square root of 2 times the square root of 4. Okay, there we go. So we have them together, and the square root of, okay, yep, there we go. Split them up. So we split them up, right? So square root of 2 times the square root of 4. That's why I have that really awkward line there. The square root of 2, I don't know, but the square root of 4 is just 2. So 2 is going outside of my radical sign, and this is really just 2 times the square root of 2 over 2 times the square root of 2. I'm sorry, not 2 times the square root of 2. I'm totally awake. Okay, you can see it right there. But can you see that something cancels? I hope you see it because it's right there. The square root of 2 cancel. And when they do, you're just left with 2. Okay, awesome job. Hopefully that practice helped. Thank you so much for watching the video, and I'll see you guys next time.